Alright, we were just about ready to plot our parabola y is equal to negative x squared plus 2. So we had all 5 of our points, so now we're just going to plot those. So an x equals 1, then y is also equal 1. We'll put that point in right here and label it 1 and 1. And then when x is equal to negative 1, y is also equal to positive 1, so a negative 1x and positive 1y. And then when x is equal to 2, we have y being equal to negative 2, so 2 and negative 2. And that's also true when x is equal to negative 2, y is equal to negative 2. So we'll plot that point as well. And now, because we know that this shape is going to be a parabola, we can draw the shape in based upon these 5 points. We have a gently outward arcing line coming down from the vertex on each side of the y-axis, and then not forgetting to label this with its equation, y equals negative x squared plus 2. And that is a fairly nice graph of our parabola. We can make it even better with more points, but that's sufficient at this time. All right, now let's take a look at our next one and see what we have. We have cubic functions next. Now cubic functions, the thing that we're going to notice about those is that cubic functions have a cube in them. So we're either going to be looking at cubic functions that will have a y is equal to ax cubed plus bx squared plus cx plus a d, or some version of those for the general form. However, those are fairly hard to graph, and we're going to be taking a look at the ones that are easier in this section. And so we're going to be looking at a y is equal to ax cubed plus d, or a y is equal to a times x minus c cubed plus d. Now, we talked a little bit about cubics before, and we found that these things had a lazy S shape like this and like this. And what we found is that when they curved upward like this was when a is positive. And when they curved downward like this one over on the right side here, we had an a which was negative. And so that's what we're going to be looking at the numeric coefficient of. The x for is to see which way we're going to go on these. Now on our cubic functions, we don't have a vertex. What we have is a point of inflection where the slope of the graph changes. So up here we have slopes that are all going one way, and then we have slopes that change here in the middle of this. And so we call this a point of inflection here. So that's what's going on in those instead of that vertex point. So we're going to take a look at the two functions here, y is equal to x cubed and y is equal to x cubed minus 1. So in the first one, the y is equal to x cubed, this is just a general function. So in y equals x cubed, we're going to see this very nice shape. And with these, we have to graph a lot more points because these things don't have the symmetry, the same symmetry that our quadratic functions do. So I'm going to start this one with the origin because that's where the inflection point is, 0, 0. And then I'm just going to start the plug and chug, but I'm going to make sure that I have those nice symmetric points still, a positive 1 and a negative 1 and a positive 2 and a negative 2. And I might need some more points, but we can get by without it. So I'm going to put in a 1, and when I cube 1, I get 1. And when I cube negative 1, I get a negative 1. When I cube 2, I get an 8. And when I cube negative 2, I get a negative 8. So now I can put in those points, 1 and 1, and that's point right there. And then I can put in negative 1 and negative 1 right there. And then we have 2 and 8. So 2 and let's see, we have 1, 2, 3, 4, 5, 6, and that would be way up off the graph. So I'm just going to put it up as far as I can. And then this one down here, it would be approximately right there, negative 2 and negative 8 as well. And then we just want to draw our nice lazy S shape through these, kind of tapering off in the middle and going off that way like that.